Adding, subtracting, and multiplying polynomials. This is three things that you have all done before, so this should be a review. At the top of your page, we need to review the standard form of a polynomial function, and I'm going to give you an example of 4x to the third plus 3x cubed, 3x squared, plus 5x minus 2. So recall that the standard form of a polynomial arranges the terms by degree in descending order. Your largest degree is 3, then 2. This here would be an exponent of 1, and technically that's an exponent of 0 that we don't write. So your exponents decrease from left to right. I'm just going to quickly do numbers 1 and 2 if you want to follow along as I write them out. For adding and subtracting polynomials, all you have to do is combine like terms. Be very careful doing it. Make sure you clearly identify the like terms, but all you have to do is add them together. The first example, we have 3x squared plus 2x minus 5 plus x squared plus 3x plus 5. When you're adding polynomials, the addition sign does not require the use of parentheses. You're just adding all terms. So I'm going to rewrite this with no parentheses. 3x squared plus 2x minus 5 plus x squared plus 3x plus 5. And I'm going to highlight my like terms. So 3x squared is common with x squared. 2x is common with 3x. And negative 5 is common with positive 5. If I add these terms together, 3x squared plus 4x squared, 3x squared plus x squared is 4x squared. 2x plus 3x is 5x. And negative 5 plus 5 is 0. So to clean this up and write our final answer, we would write this as 4x squared plus 5x. Number 2 is also adding polynomials. This time they are stacked vertically, so you just add your like terms like this. I'm going to add this just like a typical addition problem. So starting over here, we have 3 plus 4. I keep doing that. 3 plus 1, which is 4. We have negative x plus 2x, which is x. We have negative 2x squared minus 3x squared, which is negative 5x squared. And we have 6x cubed plus negative 4x cubed, which is 2x cubed. And this is your standard form function. Make sure whenever you write your final answer, no matter what, it's in standard form. Next, we are subtracting polynomials. When you're subtracting polynomials, the parentheses are important because when you're subtracting an entire set of parentheses, you need to make sure you're subtracting every term in that set of parentheses. So for the first one, we have x cubed minus 3x squared plus 5x, and then we're subtracting the entire expression of 7x cubed plus 5x squared minus 12. That means that I need to distribute this subtraction sign to all terms inside of the second set of parentheses. Once I do that, I can eliminate my parentheses. So I can rewrite this as x cubed minus 3x squared plus 5x. I'm subtracting 7x cubed. I'm subtracting 5x squared. And I'm subtracting negative 12, which is the same thing as adding 12. From here, I recognize x cubed and negative 7x cubed are like terms. I have negative 3x squared, and I have negative 5x squared. Be careful because the next one is 5x, which does not have any like terms, and then we have a constant of 12. When I subtract these, or in this case, when I add them all together, I have x cubed minus 7x cubed, which is negative 6x cubed, minus 8x squared, plus 5x, plus 12. And that's my final answer in standard form. Number 2 is the same type of problem. We have negative 6x to the fourth plus 6x squared minus the entire second set of parentheses, which is negative 2x cubed, positive 4x squared, negative x. I can rewrite this as negative 6x to the fourth plus 6x squared. We're subtracting negative 2x squared, which is the same thing as adding 2x cubed. That's what I meant to say. We're subtracting 4x squared, and we're subtracting negative x, which is adding x. 6x to the fourth stands alone. 6x squared can be combined with negative 4x squared. 2x cubed stands alone, and x stands alone. So when I add any like terms that I have in the standard form, my final answer is 6x to the fourth plus 2x cubed plus 2x squared plus x. And the last set of this note sheet is multiplying polynomials. Multiplying polynomials requires the use of the distributive property. Number 1, x plus 3 times x minus 1. The distributive property requires you to multiply the first term to both terms in the second set of parentheses and do the same thing with the second term. So in blue, x times x, that's my first arrow here. X times x is x squared. X times negative 1 is negative x. In pink, we have 3 times x, which is positive 3x, and 3 times negative 1, which is negative 3. You combine your like terms for your final answer in standard form of x squared plus 2x minus 3. Number 2, we have 2x to the fourth times 2x minus 3. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. 4 times 2x is positive 8x, and 4 times negative 3 is negative 12. When I write this in standard form, I have 4x squared plus 2x minus 12. Number 3 looks a little different because your second set of parentheses has 3 terms, but you do the exact same thing as what we have been doing. So x plus 1 times x squared plus 2x plus 3. We're going to first multiply x times x squared, which is x cubed, x times 2x, 2x squared, x times 3 is positive 3x. Next, we have 1 times x squared, which is x squared, 1 times 2x, which is 2x, and 1 times 3, which is 3. Now we need to combine our like terms. Our like terms include 2x squared and x squared, and then 3x and 2x. In the standard form, our answer becomes x cubed plus 3x squared plus 5x plus 3. And for number 4, this one gets a little bit more complex. When you have a problem that has multiple terms, or more than 2 terms, you only multiply 2 terms at a time. So if you watch what I do, I'm going to start by multiplying just the first 2 terms together. So I have 7 plus x times x minus 1. 7 times x is 7x. 7 times negative 1 is negative 7. X times x is x squared, and x times negative 1 is negative x. That's only the first 2 sets of parentheses, so I'm going to put parentheses around this expression because this is still being multiplied by x plus 3. All right, all I did was what I highlighted in green. I multiplied that out. That gives me this expression, but I am still multiplying this expression by x plus 3. So before I go ahead and multiply the next step, I just need to simplify that so it looks a little cleaner. I'm going to write it in parentheses as x squared plus 6x minus 7, and I'm still multiplying it by x plus 3. And now you need to multiply all your terms. So you can either switch these if you want the binomial, which is this one in front, but it really doesn't matter because it's multiplication. So I'm going to start by doing x squared times x, which is x cubed, x squared times 3, which is 3x squared. Then I do the next term. 6x times x is positive 6x squared, and 6x times 3 is positive 18x. Negative 7 times x is negative 7x, and negative 7 times 3 is negative 21. We have a couple of common terms. We have 3x squared and we have 6x squared. Then we have 18x and negative 7x. When we simplify this, our final answer is x cubed plus 9x squared plus 11x minus 21. And that's your final answer. All right, that's it for today. I'll be live at the end of class, so email me if you have any questions, and the GoFormative will be open until 10.